Hello, today we're going to talk about solving absolute value equations and inequalities. This is chapter 4.6 in your book. When looking at the through the text in chapter 4.6, you'll see that initially there are two types of situations you're going to come across. You'll come across situations where the absolute value symbol is only has an x inside of it, and you'll have absolute value symbols that have a variable expression inside them. Okay, we're going to handle these problems essentially the same way. In the first type, you have a little more work to do on the front end of the problem, and then in this type of problem over here, you're going to have a little more work to do on the back end. Okay, but essentially the steps are still the same if you think about them just in terms of vocabulary. So let's take a look. Steps to solving these types of problems. The first thing you want to do is make sure that your absolute value symbol is isolated, so it's all by itself. You can see in this problem it is not all by itself. There's a 5 on the same side of the equation as the absolute value of x. And on this side of the problem, it is already isolated. We have 2x plus 5 in the absolute value symbol, nothing else on the outside. So for this second type of problem, you'll see that step 1 is already done. Then we're going to write two equations. That'll be a kind of a trick to this. And really the key is to change the sign in one of the equations you make on the constant side. And I'll show you what I mean by that. And then you just have to make sure that you have solved both equations for the variable, whether it's x or a or b or whatever. So let's take a look at the type 1 problem. So in the type 1 problem, we're going to go back to our absolute value of x plus 5 equals 11. Remember, step 1 was to isolate the absolute value symbol, so I'm going to subtract 5 from both sides. And that leaves me with the absolute value of x equals 6. The next part of this problem, this is really where the nuance or the new part of this chapter comes into play. I needed to get rid of the absolute value symbols. I need to make two equations. One is x equals 6. And the other is going to be x equals negative 6. Okay. Now, like I said on the first slide, the work was done on the front end to isolate the absolute value, and then once I wrote my two equations, I'm done. There's nothing else I can do to this problem. It is solved for x. So x could be either 6 or negative 6. So in other words, if I plug in 6, the absolute value of 6 is 6. 6 plus 5 is 11. That checks out. And then I plug in negative 6. The absolute value of negative 6 is also 6. So its distance away from 0 is the same. And that's all the absolute value does. And 6 plus 5 is also 11. So let's take a look at a type 2 problem. And I always call it a type 2A problem because this is a little basic. I'm going to do a slightly more complicated one after this. So, looking at my initial equation, I see that the absolute value part of the equation is already isolated. So this guy right here is already by itself. So I'm going to go right to writing two equations. My first is going to be basically as you see it, 2x plus 5 equals 11 without the absolute value. And my second one is going to be 2x plus 5 equals negative 11. Okay? When these problems are new to you, this is the part you're going to forget. This is really the trick to the problem. Do you understand that you are changing the sign in your second equation? And now this is just two equations I have to solve. So this is a two-step equation. I'm going to subtract 5 from both sides. And I get 2x equals 6. 11 minus 5 is 6. And then I'm going to divide both sides by 2. And I'm going to get x equals 3. That is one equation. And this side over here, same thing. I'm going to subtract 5 from both sides. And I'm going to get 2x equals negative 16. I'm going to divide both sides by 2. And I'm going to get x equals negative 8. If I plug negative 8 into this equation, I get negative 16 plus 5, which is negative 11. But the absolute value of negative 11 is 11. Remember, it's only its distance away from 0. So let's take a look at a slightly more complicated problem. I call this type 2b. It's essentially the same thing. Notice I have my variable expression inside, but there's still something outside the absolute value. So again, I have to isolate this guy right here, get him all by himself. And to do that, I'm going to divide both sides by 4. So I'm just using my algebra. All right, these 4's drop off, and I get, and 24 divided by 4 is 6. So I get the absolute value of x minus 5 is 6. Now this becomes just a 2a problem where I write my two equations, changing the sign on the second equation. I can add 5 to both sides and get 11. And I can add 5 to both sides over here and get -1. Okay, so in some of these problems you may have on the variable expression absolute values, you may have to do something, move a number outside the absolute value to the other side, either by multiplication, division, or addition, subtraction. So again, isolate the absolute value, then write two equations, changing the sign of the second equation, the constant side of the second equation, and then solving for your variable. So let's take a look at an inequality. All right, and again, these are really nothing different. Everything is the same for inequalities, except when writing the second inequality, you not only change the sign, but you also flip the inequality. And then the other part is you're going to have to graph your answer. So let's take a look and see what that looks like. We have the problem. The absolute value of x minus 5 is less than or equal to -13. Okay? My absolute value is already isolated, so I can write my two equations. I'm going to write the first one as is, minus the absolute value symbol. So x minus 5 less than or equal to -13. And I also threw in a starting negative constant just so you can see that I just changed the sign. And now the part that's different for inequalities is that I'm going to have to not only change the sign, but flip the inequality. So I'm going to get x minus 5 is greater than +13. So that is the trick. That's where kids struggle, going from here to here, flipping each inequality, changing the sign of the constant side of the equation. Now again, this is a one-step problem. I'm going to add 5 to both sides, and I'm going to get x is less than or equal to -8. I'm going to add 5 to both sides on this side of this equation, and I'm going to get x is greater than or equal to 18. Now I'm going to graph those. I'm going to have my number line. I got -8 over here. I got +8 over here. They both have a bar, so or equal to, so these are solid circles. And x is greater than or equal to 18 would shade all numbers greater than 18. And then x is less than -8 would shade all numbers less than -8. So smaller, -9, -10, or bigger than 18, 19, 20, 21. I hope this helps. You may watch this video when you're creating your own tomorrow in class, so you can look over it, look at some of the points I emphasize, because you're going to want to do similar things for the problem that you have to solve. And we'll see you guys tomorrow.